Hi there, this is your recap video for last week. Just to recap on the couple of things we did. Main thing was what algebra is for, which I hope you know by now. Pause the video and think about what it is, and I'll tell you. So remember, it's to find out where two lines cross. So it could be a line and a curve, curve and a curve, curve and a circle, line and a sine wave, line and tangent curve, line and cosine, curve and a cosine. It could be anything. We want to find out where they cross. So that's what algebra is for. Yeah. So it's not just to find x. Okay. I hope you didn't say that. It's the point of it. The whole point of trying to find x is to find out where two lines cross. Okay. What we looked at was a recap of where tangent, sine, and cosine come from. So can you remember where they're from? Pause the video and think about where does tangent come from. What are the axes on the graph? What about sine? What does that come from? What does it represent? And what about cosine? So pause the video now and write those answers down for yourself. Okay, so you should have got for tangent that it comes from gradient. It's a switch between, or a conversion between gradient and angle. So if you know the gradient, you can find the angle, or if you have the angle, we can find the gradient. That's what the calculator does. When you're pressing tan 45, say, that means what's the gradient of 45 degrees, and it'll tell you. And so you type tan, which basically translates to gradient of the angle, and it switches from the angle to the gradient. And if you want to do the reverse of that, you've got to do what's called inverse, to find the inverse. So if you know the gradient, you can find the angle. So to tell the calculator that, or to flip the graph, you need to have inverse tan to the minus 1, or inverse tan. Sine, that comes from, that means height. Okay, so sine means height, but that's only when the hypotenuse is what? Hopefully you're thinking 1, because it's a normalized measure. And for cosine, it's the opposite of height, it's the opposite of sine, so it's width. So that again is when the hypotenuse is 1. So for both of those, the hypotenuse has to be 1. By the way, what's the definition of gradient? Can you remember? You might think, oh, it's y divided by x. Yeah, but why do we divide by x? It's to make it. It's to tell us what it is per one step, so that's a normalized measure as well. So the better definition for gradient is, for every one I go along, how many they go up, or how many they go down. However many is up is what the gradient is. So if that's 1, and I go up 1, the gradient is 1, because I've gone along 1, and up 1. If I go along 1 and go down 1, the gradient is minus 1. If I go along 1 and go up 2, funnily enough, the gradient is 2, because it's for every one I go along, how many they go up. Okay, that's why we divide by x. We do y divided by x to normalize it. That's why in SO katoa, the SO is divided by the h to normalize it, to make h 1, because if h isn't 1, you need to make it 1. Same for cosine, the ka is divided by the h to normalize it. And for tangent, opposite over adjacent, the adjacent is the x, so why do we divide by x? To get it to be 1. So all those things, I'm just trying to normalize it. What we looked at in the lesson was doing algebra, trying to find out where a line crosses the curve. Okay, so we looked at, I think it was something like sine theta is minus 2, something like that. And we did it in degrees, and the answer had to be between 0 and 360. And you had a couple of answers. In fact, you had 3 answers, 2 of which were between 0 and 360. So we talked about why that was. So all we're trying to do is just trying to figure out where sine theta crosses minus 2. In fact, I think it was 5 sine theta, wasn't it? That would make more sense. Yeah, 5 sine theta. So where does 5 sine theta cross minus 2? Well, first of all, what does 5 sine theta look like compared to just sine theta? So sine theta would look something roughly like that. and the highest sine can go is 1, so that's because it's normalised, so 1 and minus 1. And for 5 sine theta, we're looking at it times sine theta by 5, so that just means that everything sine theta generates needs to be multiplied by 5. So, for example, here when sine theta is 1, it's times that by 5, and it goes up there. So it's exactly the same, except just stretched up by 5. Another way of thinking about that is volume. It's like 5 times louder. Oop, not so good. Sorry, that should be in contact there at the end. So it's 5 times louder. It's known as amplitude. Okay, and then where does it cross minus 2? Well, y equals minus 2 is going to be there. So if we try and just visualise that, we can see it's going to cross here and here. So the first thing we'll do algebraically is just write sine theta is minus 2/5, because we're always trying to get to the stage of what sine theta is. And then to find theta, we need to, basically what we have here is the height, minus 2/5, and we want to know what the angle is. So to find that, we need to do the inverse, because if we have the angle, we can find the height. That's what the sine graph will give you. But what we have here is the height, so we want to know the angle, so we need to find the inverse of that. So if we do inverse sine of 2/5, which I'm doing now, on my calculator, we get, oops, I'm doing inverse sine, bear with me, inverse sine of 2/5. We get, in degrees, 23.6 degrees. Oops, that should be minus 2/5, shouldn't it? Not with it today. Minus 2/5. There we go. So minus 2/5 would be minus 23.6 degrees. Okay, there you go. Now, you might think, well, minus 23 degrees, where's that? Well, it's over here somewhere. And that is not of any use to us, because we want an answer that's between 0 and 360. And the calculator is actually programmed to give you answers that are essentially nearest the y-axis, so it's actually programmed to go from minus 180 to 180. And so it's finding that solution for you first. Let me do that again. There we go. So that's not very well drawn. A bit more like that, and that, and then that, like that. Yeah, something like that. Yeah. So that's no use to us, is it? Because I want an answer between 0 and 360. So to find this, the actual solutions, what we're going to do is we're going to just use the fact that it's a repetitive, what's known as periodic function. So what's going to happen is it's going to repeat itself every 360 degrees. So that means that it's going to be the same place all the way over here. That's going to be the same value. So that is effectively minus 23 degrees, that distance there, because that distance is. So for that, to find that one, I'm just going to do 360 minus 23.6. So that's 346.4. Nope, 336.4 even degrees. So that's that one, and then the other one is here. That one, because it's a symmetrical curve, it must be 180 plus the same distance. Sorry about my rubbish drawing here, but symmetry would be that that's the same distance to there. So it's 180 plus 23.16, so that's 203.6. And there will be our two answers. Let me rub that out, make it a bit clearer. So 336.4 and 203.6 degrees. Okay, so that is really, like I tried to say to you, if you remember our very first lesson, what's algebra for? Is find out where two lines cross. A lot of A-level is just trying to find out where two lines cross. It just doesn't always seem like it. It seems like different things, but you just do a variety of different lines, Here's a classic example of it. I dug up a paper for us to look at, which I thought had an interesting question in it we could have a go at. Oh, that's not it. There we go, number 7. So sketch the graph of y equals tan x. Well, you need to, so there you go straight away. You need to know what tan x looks like. So now you know that it does and why it does. Write down the two solutions of the equation tan x is tan 61 in the interval 0 to 360. So what's that going to look like? So tan 61 is a gradient, because it's saying gradient of angle 61. Okay, so that means we're going to just do some algebra, because what it's saying is tan x is equal to some number. Where does that happen? So obviously one of them is 61, yeah, because that's going to be the same thing. Tan 61 is tan 61, but because tan repeats itself every 180, it's going to be 241 as well. Part C, given that sin theta plus cos theta is 0, show that tan theta is -1. So as we talked about, when we talked about sine being height and cosine being width, normalised measures of them anyway, because it needs to be, it's only when it's 1. So if sine is height and cosine is width, I've done that the wrong way. It's not going to be that way. Not with it today, sorry. So sine is height, cosine is width. If I divide one by the other, I'll do it that way. I've got sine over cosine is height divided by width. Right? So now I know you know that sine over cos is tan theta, more accurately. They should be thetas. But why? Well, because height divided by width is gradient, isn't it? That's a definition of gradient, or one of them. So tan theta is gradient, we know that already. That's the definition of tan. So it's not surprising that sine over cosine is tan, because it's just height over width. So if we divide both of these by cos, we're going to get sine over cos plus cos over cos equals nothing. So that's sine over cos is tan plus cos over cos is 1 equals nothing. You can see the next line is going to be, sorry, this mouse is rubbish, tan theta equals -1. Hence solve the equation this in the interval that. So this is another one. It's just more algebra, isn't it? Trying to find out where this line crosses the other line. So sine x minus 20 plus cos x minus 20 is just this thing, but theta is x minus 20. Sine of this plus cos of this is 0. See, it's exactly the same thing. And we've just said that this is tan theta is -1. So I can replace that theta by x minus 20. So tan x minus 20 is -1. And this is the same thing. We're trying to find out where those two things cross, because that's what algebra is for, isn't it? So we're going to find out where -1 crosses x minus 20. Algebraically, what's going on is all we're going to do is just do inverse tan. It's going to give us x minus 20 equals 135, that'll turn out to be. So inverse tan of -1 is 135. Okay, and the second solution to that would be that plus 180, so that's 315. So x will just be those 20s added on. So they're both degrees. But why is that? What effect does this have? Or rather, what effect does this -20 have on the tan x graph? Well, it's going to move, as you can see in the answers, it's going to move it 20 to the right. It just translates it 20 to the right. That's all it does. And that's why the two solutions are 20 more than you would expect, because the whole thing just moved 20 to the right. And I think that's the next question. Describe the single geometrical transformation that maps the graph of that onto that. well, it moves 20 to the right, 20 degrees to the right. I'm going to leave this last one for you to have a go at, and you can get back to me with what you got. So the curve y equals tan x is stretched in the x direction with a scale factor a quarter to give the curve with equation this. What's happened, basically. Write down the expression for f of x. Okay, so have a go at that. I want an email with your answer, please, and look forward to receiving it. Okay, so I thought that's covered everything that we did. Again, as usual, got any questions, just get in touch, but I look forward to hearing from you with that answer anyway. Okay, speak soon.